On the morning of December 19th, everything changed. Not because of what 3i Atlas did, but because of what it triggered. For months, astronomers had watched this object bend expectations, its alignment anomalies, its energy budget mystery, its sunward jets. All of it pointed to something unnatural. But at 3:14 a.m. UTC, high-priority satellites across US Space Force orbital infrastructure received a single command: deploy. Within hours, a sensor swarm was launched, a coordinated lattice of hyper-responsive detectors, relays, and optical trackers across Earth's geosynchronous and polar orbits. The reason? A sudden localized shift in the electromagnetic environment surrounding 3i Atlas, followed by a temporary loss of signal from a trio of critical tracking satellites. This wasn't a test, it wasn't a drill, and it wasn't theoretical. For the first time, a military space agency treated an interstellar object not just as a curiosity, but as a threat vector. When tracking objects from deep space, especially those designated as interstellar, astronomers expect unpredictability, but only within the bounds of natural law. Ice sublimates, solar wind perturbs, outgassing jets shift an orbit subtly. But on December 19th, shortly after 2:40 a.m. UTC, 3i Atlas did something that didn't just bend the rules. It acted as though it was following a script that had nothing to do with comets. What Space Force analysts witnessed wasn't random, wasn't chaotic, and wasn't explainable through conventional sublimation. It was precise. Too precise. At first glance, it looked like a maneuver. Over the course of 5 minutes, the interstellar object shifted its trajectory ever so slightly. A clean, non-chaotic drift away from the Sun, angular by less than a degree, but significant enough to trigger alerts in every observatory that had it under optical lock. The movement was not only smooth, but matched the acceleration profiles used in known spacecraft when performing deliberate course corrections. It wasn't the ragged kick of thermal jets bursting unevenly from a sunlit side. It was elegant, fluid, engineered. Tracking data showed a near sinusoidal curve, something rarely seen in natural bodies but often modelled in simulations of light sail propulsion systems. This kind of movement isn't driven by ice turning to gas. It's driven by geometry, by reflectivity, by feedback. One NASA observer noted that the motion looked almost like a recoil from sunlight, and yet it didn't rotate, it didn't tumble, and no trail of particulate debris followed in the wake. That silence, visual, thermal, and electromagnetic, is what made the anomaly deafening. This specific maneuver raised alarms for another reason: its timing. It occurred during a window where several military satellites were passing into overlap with the projected path of 3i Atlas. These were not science satellites. They were defense satellites, designed to monitor missile, launches, battlefield infrared signatures, and unauthorized orbital activity. And as soon as 3i Atlas made its shift, 3 of those satellites experienced brief but synchronized telemetry losses. Normally, a non-gravitational acceleration is attributed to outgassing, gas jets from sublimating ices creating a sort of microthrust. But those forces don't happen on command. They don't fire across multiple surfaces at once, and they definitely don't maintain consistent directionality over multiple observation points. In this case, the object's motion did just that. It suggested something was choosing to adjust, not reacting, but initiating. Not random outbursts, but calculated motion. The implications of such a maneuver ripple outward. If this is a comet, then it is the most coordinated natural body ever recorded. If it is not a comet, then it is responding to physics in ways that resemble purpose. That single shift, lasting less than 300 seconds, changed everything. It broke models, it forced recalculations, and most importantly, it activated protocols that had only ever existed in the planning stages, among them the sensor swarm deployment. But that's the part that remains quietly stunning. It wasn't just what 3i Atlas did, it was what it triggered. The moment that smooth acceleration was confirmed, something shifted behind the scenes in military space infrastructure. Not because it posed an immediate danger, but because the object for the first time began behaving like something aware, something that could navigate. That sudden, silent push away from the Sun wasn't just physics, it was a message. And the first response wasn't from scientists, it was from defense. roughly 10 minutes after 3i Atlas executed its strange and silent acceleration away from the Sun, the incident deepened. 3 satellites, each part of a high-priority US surveillance system orbiting over different longitudes, simultaneously dropped off the network. These weren't aging weather satellites or experimental payloads. These were hardened, shielded, redundancy-equipped military eyes in space, positioned to monitor ballistic threats, infrared flashes, and unregistered orbital movements in geostationary space. And they all failed at once, in perfect synchronization, for precisely 92 seconds. Space Force analysts labeled it immediately Zone B blackout. When multiple satellites fail together, especially over separate regions, the immediate suspicion is external interference. That could mean solar storms, debris collisions, or adversarial jamming systems. But on December 19th, none of those conditions were present. Solar weather was calm. No solar flares had emerged from active regions in the preceding 24 hours. The debris catalogue showed no recent breakups or fragmentation events, and no adversarial signals were detected from any ground-based origin. In short, nothing around Earth explained what had just happened, but something far beyond Earth did. At the time of the blackout, all 3 satellites had a shared line of sight, 3i Atlas. Though hundreds of millions of kilometers distant, the object's position in space aligned almost perfectly with the satellite's tracking vector. That meant that all 3 were using 3i Atlas's silhouette as a spatial anchor for calibration, a standard technique for validating position and stability in mid-orbit. And then, abruptly, all signals passed through that anchor point and fell silent. Initially, Space Command suspected an onboard failure cascade, but diagnostics told a different story. The satellites didn't shut down, they didn't glitch, they kept recording telemetry. What failed was communication. For 92 seconds their transmissions were scrambled, not by noise but by redirection. In technical logs, the status wasn't offline, it was loss of lock. And here's where it gets strange. The blackout wasn't chaotic, it was clean. The transition in and out of the signal drop was smooth, with no gradual corruption or radiation buildup. It looked like a switch had been flipped, and then flipped back, like a signal had been intentionally bent or absorbed in a corridor of space, no more than a few thousand kilometers wide, millions of kilometers from the source satellites. That's when the term electromagnetic occlusion corridor was whispered inside the space surveillance network. A corridor is different from a shadow. A shadow blocks light. A corridor redirects it. The implication was chilling. Something near or inside the field surrounding 3i Atlas was manipulating the signal, possibly using plasma density, active field shaping, or a kind of transient bubble, forcing signals to curve or collapse. This kind of interference is known in theoretical space warfare, but only at ranges of a few kilometers. For it to occur across multiple satellite paths from an interstellar object was unprecedented. No solar system body has ever done this, not even during the strongest CME events in recent years. By the end of the day, all 3 satellites resumed normal function. No damage, no permanent corruption. But they returned with identical blind spots, short gaps in their logs where the sensor input should have been. It was as if the satellites saw nothing, but the systems downstream reacted. AI modules that sought orbital patterns issued soft alerts for transient object shielding. This isn't a code for comets, it's a flag for when an object obscures tracking. In short, the systems designed to watch for cloaking behavior in hostile satellites flagged 3i Atlas for doing the same thing. It didn't just vanish, it cloaked, or at least it acted like it did. And for 92 seconds, the most sophisticated surveillance network on Earth had to admit that it was blind. By midday on December 19th, the decision was made behind closed doors. Within a secure command node of US Space Force's Orbital Defense Division, the order was issued: deploy the sensor swarm. This protocol had only existed on paper and in simulation models. It was built for one terrifying scenario: not invasion, not asteroid impact, but non-atmospheric electronic obfuscation from an unidentified object. In simpler terms, an unknown craft enters a surveillance blind spot, shows behavior incompatible with natural motion, and triggers satellite data failure. 3i Atlas had just done all 3. The sensor swarm wasn't a single device. It was a coordinated net of dozens of microsatellites, high-gain receivers, signal repeater drones, and spectral monitors spread across multiple orbital bands. Their purpose wasn't to attack, disable, or even intercept. Their mission was far more precise: observe what could no longer be seen through normal means, and most importantly, detect if the object was broadcasting anything, not just signals, but intent. When the swarm deployment was triggered, multiple backup systems went live. Disguised as scientific platforms, several dormant infrared telescopes and decommissioned radar arrays were reactivated within minutes. From Alaska to Diego Garcia, from Guam to silent installations in the Azores, a new layer of Earth's early warning net came online. The moment the swarm locked onto 3i Atlas, they reported something Space Force had not anticipated. The object was calm, no spikes in radiation, no heat bloom, no tumbling mass. From a distance, it still looked like a comet, but its position within the swarm's field triggered something deeper. An analysis module used in electronic warfare. It ran a comparison scan. The return signal pattern was almost identical to a known stealth-capable drone. That shouldn't have been possible. This isn't a software hallucination. These are signals interpreted by orbital infrastructure hardened against spoofing and decoy deception. These sensors don't compare objects to catalogued spacecraft, unless the return signatures fall within an engineered range. That's exactly what 3i Atlas returned, a pattern suggestive of deliberate reflectivity control. The swarm quickly began triangulating. Each node attempted to remap the object's shape, using thermal pulse returns and photon bounce patterns, and that's when something even stranger emerged. The object didn't look round or irregular. It reflected light as if it had angles, planar shifts, flat surfaces that phased in and out of clarity, depending on where each satellite was positioned. It was behaving like a low-profile radar-evading object, built to vanish, not to shine. More than that, the swarm reported delay loops in reflection. That means photons sent toward the object were returned not instantly, but with a microsecond-level delay inconsistent with the expected cometary materials. This delay is often found in metamaterials, exotic structures engineered to interact with light in unusual ways. Why deploy the sensor swarm? Because something was mimicking active defense behavior, not to attack, but to vanish. And when something chooses to vanish just as you're watching it, you assume it knows you're watching. This wasn't about a threat assessment, it was about redness. The moment an object from another star system demonstrates the ability to distort signal, evade detection, and alter its own visibility, it graduates from curiosity to case study. Space Force didn't need proof it was technology. It just needed proof that it was acting like technology. And the sensor swarm? It saw enough to make that conclusion official. The moment the sensor swarm achieved full triangulation, its first priority was thermal mapping. In theory, this is the most straightforward form of detection. Every object in space, from dust grains to starships, emits infrared radiation, heat energy that flows from warm bodies into the cold vacuum. Infrared readings don't lie. They can't be cloaked. They can't be hidden, not without active countermeasures. And yet, when 3i Atlas came into range, the results triggered more confusion than clarity. The leading edge of the object, facing Earth, not the Sun, registered hotter than the sunward side. That alone defied expectations. Standard thermodynamic models of comet behavior predict that the face exposed to solar radiation should be the warmest, with a steep gradient tapering toward the night side. But what the swarm detected was inverted. A patch of heat sat on the wrong hemisphere. At first, analysts assumed it was a calibration error. Instruments were checked, mirror alignments were rerun, signal distortion from solar radiation was ruled out. But the anomaly persisted across multiple satellite nodes. The temperature distribution wasn't fluctuating, it was stable. A smooth band of elevated infrared intensity maintained its position relative to the object's vector, as if it were internally managed. Then came the second surprise. The tail, normally a loose cloud of particles emitting a predictable thermal trail, showed behavior completely inconsistent with standard comet models. Instead of trailing off gradually with distance, the tail absorbed heat. Its thermal signature dropped below cosmic background levels, effectively rendering it colder than space. In data terms, it presented as a negative radiation zone, something that should be physically impossible. This is what infrared scientists call reverse emissivity, and it's a phenomenon almost never seen outside of carefully engineered materials like supercooled cloaking panels or heat-absorbing plasma buffers used in experimental spacecraft. For an object of natural origin, no known chemical process allows its tail to sink energy from its environment faster than space radiates it. The tail, in essence, was acting as a thermal sink, and that meant one thing. Energy was not just being radiated, it was being redirected or stored. That interpretation was backed by another layer of data. A subset of the swarm's sensors used interferometry to compare phase delay in thermal emissions, essentially watching for the rhythm of the heat flow. What they found was structured delay. The heat wasn't dispersing randomly, it pulsed, it echoed. It moved along a pattern resembling stage dissipation, a technique used in advanced cooling systems where energy is offloaded in stages to prevent detection or structural damage. This tail wasn't shedding heat from sublimating ice. It was managing heat like a thermal exhaust system. And then came the quietest signal of all, so subtle that it took hours to confirm. The object's heat profile oscillated in exact rhythm with the Earth's satellite ping rate. In layman's terms, every time a sensor tried to read it, the object shifted its heat signature. Not completely, not enough to avoid detection, but enough to complicate it. The analysts had seen this behavior before, in stealth drones designed to wobble their infrared footprint just enough to avoid missile lock. It's called thermal jitter, and it's not random, it's calculated. So what does this mean? To the military, it means something simple. The object is aware of observation. Infrared signatures are supposed to be passive. You radiate what you radiate. But 3i Atlas behaved like a system tuned to light, managing its visibility not with materials alone, but with method. Either it is composed of the most exotic cometary material ever discovered, or it has an embedded mechanism capable of redirecting thermal energy in response to surveillance. In either case, it isn't just reacting to the sun, it's reacting to us. If the thermal readings raised eyebrows, the electromagnetic data nearly shut down the discussion room. EM fluctuations are common in space. Solar flares, coronal mass ejections, and even pulsar echoes generate waves that ripple across the heliosphere. Instruments on Earth and in orbit track these daily. But what occurred near 3i Atlas on December 19th wasn't part of any known solar output. It didn't originate from the sun. It didn't ride in on a wave from elsewhere. It started near the object, and it had a signature. At 03:28 am UTC, just 14 minutes after the thermal inversion event, the swarm's wideband EM sensors registered a clean spike in low-frequency radio bands. It wasn't chaotic like solar windbursts. It wasn't gradual like background magnetic drift. It was instantaneous. The amplitude rose sharply, plateaued for 17 seconds, then collapsed. It looked engineered, as if something had powered up, pulsed, and shut down. What followed was even stranger. A compression wave passed through the swarm's formation. Not a shock wave, but a localized shift in space plasma density. That's the region of the solar system filled with charged particles. Under normal conditions, plasma density varies slowly and predictably, but this wave was tight, fast, and spherical, and at its center, 3i Atlas. Ground-based radio observatories also caught the event, though at a delay due to signal propagation. A flare-like distortion appeared in the megahertz range, but instead of broadening, it narrowed. A laser-thin corridor of signal noise that faded as quickly as it came. The pulse was centered on the object's location in the sky. A dead match. Engineers from the Very Large Array in New Mexico, tasked with reviewing the waveform, called it unnatural coherence. Coherence refers to how structured and predictable a wave is. Natural phenomena scatter, they drift. But this wave was tight, focused, deliberate. The kicker: the frequency band it occupied was almost identical to the ones used in early spacecraft telemetry. That's not a casual coincidence. Those bands were chosen in the 20th century because they cut through noise and ionospheric interference. This EM pulse didn't just flare in an empty frequency, it targeted a clean corridor, as if to be seen. Space Force analysts created a moment-by-moment map of the fluctuation, overlaying it with the known solar wind pattern from that hour. The distortion moved against the solar wind, not carried by it, but resisting it. That movement can only happen if the source is generating its own field strong enough to shape local plasma. What causes that? In theory, active propulsion, not rockets, not jets, field-based movement. One hypothesis was floated and quickly redacted from public analysis: magnetic lensing. That's the act of warping space plasma using rapidly oscillating EM fields to deflect incoming particles or radiation. It's theorized for shielding, for cloaking, for managing incoming force. The implication: the object was shielding itself from observation or from solar influence. But the EM pulse didn't last. After 23 minutes of faint echoes, the field collapsed. The local plasma returned to normal, but in that short window, nearly every long-range radio telescope in the network recorded the same drop in ambient noise levels, like the region had emptied itself of static. In military telemetry, this kind of anomaly is referred to as EM blanking. It's how radar jamming systems work. It's how stealth technology hides its signature, not by staying invisible, but by making the space around it silent. And for nearly half an hour, 3i Atlas made space itself go quiet. In the hours following the electromagnetic pulse near 3i Atlas, something else began to shift. This time, not in space, but on Earth itself. Deep within the data streams of geomagnetic observatories scattered across the planet, from polar regions to equatorial stations, researchers noticed a pattern. At 0351 M UTC, precisely 23 minutes after the pulse began, Earth's magnetosphere responded with a ripple. It wasn't a geomagnetic storm, it wasn't a spike, and it wasn't driven by any solar wind event. Instead, what occurred was a flutter, a subtle, wave-like perturbation in the magnetosphere that lasted exactly 48 seconds. At first, analysts dismissed it. A momentary fluctuation in the geomagnetic field isn't rare. Earth's magnetic environment is constantly in motion, shaped by solar cycles, charged particle influx, and even the planet's own internal dynamo. But this one was different. It wasn't global, it was localized. The disturbance began over the southern Indian Ocean, spread in a westward arc across the Pacific, and vanished just as it reached the western seaboard of the Americas. This wasn't weather, it was a signature. The wave pattern resembled what scientists refer to as a geomagnetic impulse event, a rare phenomenon typically triggered by sudden injections of high-energy particles into the near-Earth environment. But no such injection had been detected. The solar wind was calm, there was no CME, no cosmic radiation event. The ionosphere was quiet, yet the instruments didn't lie. Fluxgate magnetometers picked up the anomaly across 3 continents. The frequency of the perturbation wasn't random. It matched a known waveform, 0.13 Hz. That number might seem meaningless, but in Earth-based electromagnetic research, it's significant. It's the same resonant frequency used in deep communication systems, like those used to penetrate oceans or even underground structures. It's a carrier frequency, capable of travelling long distances through obstacles without dissipating, and that's where the story turned darker. If a localized field pulse travelled through Earth's magnetosphere at exactly 13 Hz, and if it originated not from the Sun, but from deep space, then what was it carrying? Military analysts reviewing the geomagnetic logs noticed something else. At the precise moment the impulse began, several undersea listening stations designed for seismic detection registered micro-vibrations. These weren't earthquakes, they weren't tectonic. They were electromagnetic to physical transductions, energy entering Earth's outer magnetic shell and bleeding into the crust as harmonic resonance. This isn't normal comet behavior. To trigger a reaction in Earth's magnetosphere, an object must either generate a massive radiation pulse, or it must be manipulating its own field in such a way that it couples with the larger planetary environment. That's what coupling is. Not a collision, but a handshake. 3i Atlas wasn't just altering space around itself. It had, for a brief moment, touched Earth's magnetic fabric. More disturbing still was the timing. The ripple appeared exactly 1 full solar rotation, 27.3 days, after the object first passed a critical angular alignment with Earth's magnetotail, a position where space weather connections can be established naturally. But nothing happened then. Instead, the signal came now, after its anomalous acceleration, after the blackout, after the sensor swarm was deployed. To physicists tracking it, the sequence felt deliberate. Was this cause and effect? Or was it part of a loop, an object responding not just to solar energy but to Earth itself? For decades, scientists have debated the idea of magnetosphere interaction with deep space phenomena. Some believe interstellar objects can carry their own magnetic fields. Others suggest that objects with high conductivity, like nickel-rich meteorites, can act as field amplifiers when exposed to solar radiation. But what happened on December 19th wasn't theoretical. Earth responded. A ripple moved through the sky, and that ripple came from somewhere else. As Earth's magnetic field stirred and the EM pulse dissipated, attention shifted back to something stranger, something visible but unexplainable. Telescopes across 3 continents reported an anomaly in light tracking, but not from atmospheric distortion. This disturbance wasn't happening in the sky above, it was happening in space itself. At 04:06 AM UTC, the optical systems aboard multiple tracking satellites began returning faulty data. Not corrupt, not blank, just misaligned. Star positions near 3I Atlas appeared to drift, not because the object moved, but because the light around it refracted inconsistently. It was as if the space surrounding 3I Atlas had bent. This wasn't gravitational lensing. The object is far too small to curve light like a black hole or a planet, and yet the starlight behind it shimmered, warped, and shifted, as if being pulled sideways by a ripple in invisible glass. This distortion was eventually classified as an optical misalignment event, a term used in military space telemetry to describe situations where visual tracking systems begin failing due to light-bending interference. Normally, that would mean high-temperature plasma clouds or debris fields, but here there was neither. Infrared and ultraviolet lenses showed nothing. No debris, no scattering. But visible light was bending. The region around the object developed a kind of mirage effect, similar to heat waves rising off hot asphalt, except it was occurring in the vacuum of space, in near-zero thermal conditions. Ground telescopes confirmed the distortion. Deep in Chile's Atacama Desert, one of the world's most stable optical observatories caught the anomaly using a wide-field lens. They expected a cometary blur. What they saw instead was a spatial ripple that made 3I Atlas look like it was behind water. The implications were immediate and disturbing. Light was entering a region of space and exiting at incorrect vectors. That requires a refractive medium, something with a varying index of light transmission. In Earth terms, that's air, water, or glass. In space, it's plasma, unless you're dealing with engineered field distortions. Plasma lensing is a theoretical concept in which charged particles shaped by strong EM fields can bend light artificially. It's been proposed as a method for cloaking spacecraft. It's been tested, barely, in laboratory conditions. But to see it on this scale passively occurring around a fast-moving object from another star system, that was unprecedented. Satellite data showed that the distortion was not static. It rotated with the object. That meant it wasn't a natural field disturbance. It was anchored to 3I Atlas. Worse yet, the distortion had memory. When one of the satellites corrected for drift and realigned with the expected object coordinates, the distortion followed the correction, adapting its shape as if learning how the sensor adjusted. In tracking telemetry, this is known as adaptive refractive response. In short, the object was watching back. What had started as a camera glitch quickly became a data flood. Every optical system in range reported the same phenomenon. The light distortion wasn't random, it was repeatable, it was responsive, and it was behaving like a field designed to prevent high-fidelity imaging. This wasn't about being seen, it was about being seen wrong. With sensor readings piling up and real-time tracking systems beginning to destabilize, the decision was made to do something that hadn't been done in years: reactivate the legacy systems. These were old satellites, retired units, dusty ghosts in silent orbit, once used, then archived, floating relics of past surveillance missions, left on standby in the event of an unthinkable anomaly. December 19th was that event. The command came from Strategic Control Node Bravo. Bring up the Dark Fleet. Satellites from the early 2000s, once used to monitor advanced stealth aircraft and orbital weapon tests, were powered back on. Their systems weren't elegant, their lenses were not the best, but they had something newer satellites didn't: passive reflection algorithms. Unlike modern adaptive sensors, which rely on predictive targeting and AI pattern recognition, these legacy birds used brute force photometric reading. They measured everything that bounced off an object: infrared, microwave, even cosmic background interference. If 3i Atlas was hiding in any frequency, these satellites would see the gaps. Within minutes, the old systems were online. Their positions were corrected, solar panels extended. One by one, their eyes opened, and what they saw was nothing, not a blackout, a hole. In every spectrum, 3i Atlas appeared as an absence, not of light, but of interaction. Like the region it occupied was no longer transmitting any signal, no light, no heat, no radiation, as if it was wrapped in a kind of absorptive layer. One satellite operator described it as staring into an unplugged screen that used to show stars. This was not invisibility. It was optical suppression, an engineered absence. To the old satellites, it looked like 3i Atlas had entered a region of physics that modern tracking couldn't pass, and that the old systems could barely detect. And yet, when one of them tried to ping the object with a low-frequency radar sweep, a pulse bounced back. Just one. Just enough to say, yes, I'm here. Then silence again. As telescopes tracked 3i Atlas throughout the night of December 19th, a subtle but undeniable change began to appear across thermal infrared imaging channels. For days, the object had registered a consistent low-temperature profile, typical of a dark, reflective nucleus partially warmed by the sun. But sometime around 3:15 a.m. UTC, that pattern broke. Not suddenly, not dramatically, but in a way that caught the attention of everyone monitoring it. Because what emerged wasn't random heat. It was structure. Instead of a uniform warmth radiating outward, the thermal cameras began detecting segmented zones, discrete hot and cold regions along the object's surface. At first it looked like noise or instrumental error, but the patterns repeated across telescopes located thousands of kilometers apart, including the European Southern Observatory and the Infrared Telescope Facility in Hawaii. This wasn't a glitch. The object had changed its heat signature, and what's more, the heat wasn't spreading naturally. It was pulsing. Pulsing implies control. Pulsing implies internal coordination, and the rhythm didn't match any solar flare, cosmic ray bombardment, or magnetic interference. It repeated every 12 seconds. Too long for a comet jet, too short for radiative cooling, and far too organized to be chaotic. Some sections would grow hotter, while others cooled in a mirror pattern, and then it would switch. This modulation resembled an alternating signal rather than any natural phenomenon. And if that wasn't strange enough, those thermal zones didn't rotate with the body. They held fixed positions, like a grid responding to something internal. The question that arose immediately: what could cause a non-luminous object to exhibit organized heat zones like this? Several theories were quietly circulated. One posited that internal cavities within 3i Atlas were opening and closing in rhythm, releasing controlled bursts of energy, almost like a kind of respiration. Another suggested unknown materials or coatings on the surface that were responding to solar input in a way we've never seen before. But one theory kept surfacing in private forums. What we were seeing was power regulation, not outgassing, not natural decay, something more like internal management of energy flow, as if the object was adjusting its thermal balance intentionally. The implications were staggering. A natural body doesn't organize heat like this. It warms up under sunlight and cools in shadow. It doesn't pulse. It doesn't form equidistant zones. And it certainly doesn't keep the thermal boundaries locked in place while drifting through solar flux. The moment analysts overlaid the temperature shifts with the prior sensor blackout and the non-gravitational drift event, a chilling realization set in. The heat pattern looked like the activation phase of something, not decay. And yet, the object remained completely silent in all other bands. No spikes in radio emissions, no visual flares, no outgassing jets, just this quiet, methodical shifting of heat, repeating, cycling, calculating. When defense agencies picked up this data, they didn't issue statements. They simply increased bandwidth on their classified deep sky tracking networks and requested exclusive access to several thermal telescopes for the next 6 hours. Something about the pattern wasn't just abnormal. It looked familiar, as if it matched something they'd modelled. And so, as the thermal signature began its 9th pulse, teams around the world stared at their screens. Not with curiosity, but with the creeping sense that 3i Atlas wasn't just reacting to sunlight, it was preparing for something, a maneuver, a release, a signal, or perhaps a transition. Either way, the temperature didn't lie. The comet had come alive, and now it was breathing. It was just past 4:20 a.m. UTC when a network technician at a private observatory in Chile noticed something he couldn't explain. A stream of deep space data, intended for internal calibration, was being duplicated and echoed across channels that shouldn't have been connected. At first, it looked like a minor software glitch, until it became clear the signal wasn't local. The anomaly wasn't within their system. It was coming from the direction of 3i Atlas. 3 observatories, in Chile, Australia and Greenland, all reported the same strange pattern. They were each receiving reflections of their own data, bounced back milliseconds later, routed through a frequency shift that pointed directly to the region of space near the object. This wasn't a radio echo. It wasn't atmospheric distortion. It was a tightly mirrored relay, a loop, almost as if the comet itself had begun reflecting signals back to Earth, encoded in a slightly modified format. The shift was just enough to suggest intent, not interference. The term data relay loop started circulating among analysts, but what it really meant was unclear. This wasn't a form of communication as we know it, not a message, not a broadcast. It was more like passive interception, like a node listening and bouncing back information in a slightly changed tone. This kind of behavior is characteristic of probes or surveillance systems, not of icy natural bodies drifting from interstellar space. Some scientists tried to downplay the event. They proposed that solar wind could interact with a metallic or plasma-rich structure in a way that deflected radio waves back toward their source. But that didn't explain the frequency shift. It also didn't explain why the relay only happened with Earth-origin signals. Random noise in space is abundant, and yet, the only signals being caught in the loop were Earth-based pings, guidance calibration lasers, deep space radar sweeps, and passive thermal sweeps, and the reflected data didn't come, backscattered. It came back refined. One sequence in particular disturbed military analysts. A defense satellite over the Pacific sent out a silent ping to calibrate its low-frequency sensors, a routine task. But exactly 2.4 seconds later, that ping came back. Not identical. Slightly modulated, compressed, and time-aligned with the trajectory of 3i Atlas. That was no natural echo. It was something acting like a lens, a translator, or a processor. And that made it impossible to ignore the possibility. The object wasn't just interacting with energy, it was interpreting it. From a defense standpoint, this was now a tactical risk. Because if the object could reflect and reprocess signal data, even passively, it meant it could map global sensor networks, learn scanning rhythms, and adapt. Not just in theory, but in real time. And the question was no longer what it was doing, but why. Teams began running pattern comparisons with historical satellite behavior, and what they found was a disturbing match. The relay loop bore resemblance to classified modelling of passive electronic warfare probes, devices designed not to jam, but to learn. Systems meant to remain invisible until they understood their environment well enough to act. That model had been theoretical, until now. So, as the data loops continued into the night, quietly intercepting Earth-based signals, a new level of alert was triggered across secure channels. 3i Atlas wasn't just giving off strange heat or drifting oddly. It was now integrated into the information sphere, feeding on data, reflecting patterns, and learning. The moment it started mirroring calibration pulses, one conclusion began to crystallize. This wasn't a passive object, it was a system, and it was now fully aware of Earth's eyes watching it. By the early hours of December 19th, most agencies assumed they understood the basic silhouette of 3i Atlas: irregular, elongated, slightly tumbling, with a faint rotational drift. But at exactly 5:13 a.m. UTC, everything changed. A low-angle sequence of optical captures from the ALMA array in Chile, synchronized with polarimetric data from the South African Astronomical Observatory, revealed something no one expected. The shape wasn't consistent. It was flexing. At first, this appeared to be a tracking anomaly, perhaps caused by atmospheric shimmer or lens diffraction. But when the composite frames were stacked and corrections were applied for Earth's rotation, the conclusion was unmistakable. The object's form had morphed, subtly but measurably, and not in a random way. It was as if the edges of the comet had collapsed inward slightly, flattening the anterior third of the object. The tail geometry remained unchanged, but the front, previously bulbous and convex, had narrowed into a wedge. This shift occurred gradually over a 40-minute period and returned to its previous state by dawn. Yet, the movement was captured independently by multiple instruments across the globe. This wasn't visual noise, it was structural deformation. Natural comets don't change shape like this. At most, they break apart or rotate. They do not reshape themselves in symmetric, reversible ways. The implications were jarring. Some likened it to a living cell contracting. Others described it more like a machine adjusting its aerodynamic profile. But either way, it pointed to internal structure, something that could bend, hold tension, and then release. Astrophysicists scrambled for natural explanations. Could solar radiation pressure, in combination with embedded volatile pockets, create temporary flex patterns? Could tidal forces from Earth or the Sun exert enough torque to reshape a comet's outer layers? The math didn't support it. The forces involved were too weak, the timing was too clean, and the reversal too perfect. What made the event even more chilling was the alignment. The shape change occurred as the object passed into a trajectory that allowed full face-on solar illumination, almost like it was reacting, or adjusting, to maximize energy absorption or signal reflection. That correlation wasn't lost on engineers. The pattern mirrored behavior seen in early solar sail experiments, shifting surface area to optimize light interaction. The idea that a 10-kilometer wide object could subtly change its form for interaction efficiency introduced a terrifying possibility. If this was a vessel, it was adaptive. If this was a structure, it was dynamic. And if this was a probe, it was evolving. Several teams ran contour models on the before and after frames. The conclusion? The object had minimized its reflective cross-section, reducing its solar-facing area by 16%. That would reduce its visibility to most Earth-based sensors, especially those in geostationary orbit. Why would a natural body do that? When this analysis reached defense agencies, the response was immediate. Telescope allocations were reprioritized, asset tracking systems were resynced, and several ground-based radar stations were quietly reactivated under classified protocols. A maneuverable, shape-shifting object of unknown origin with signal mirroring and thermal modulation capabilities had now passed a threshold. It wasn't just an object anymore, it was an operator. And as the shape slowly returned to its original profile, just before the limb of the Earth caught the morning sun, one final clue remained. A faint trail of microfragments had been released during the flex. They weren't random, they formed a linear grid, not a debris field, but a pattern. At 6:42 a.m. UTC, a routine sweep from NASA's Solar Dynamics Observatory picked up a faint but undeniable distortion near the rear of 3I Atlas. What was supposed to be a stable tail formation, a stream of particles pushed outward by solar wind, was no longer behaving as expected. Instead of stretching directly away from the sun, the tail began to bend forward, curving toward the nucleus itself, and then it flipped. Comet tails don't do this, at least not under any known solar or magnetic conditions. Every known comet follows the same basic physics. The tail always points away from the sun, driven by the pressure of radiation and solar particles. But here, with 3I Atlas, the tail did something almost mythological. It reversed direction and aligned toward the solar wind source, as if attracted by it. Initial theories suggested a rare magnetic interference, perhaps caused by a localized solar flare. But that didn't hold up. There was no flare at that time. The solar wind was steady, if not mild. Yet somehow the tail bent and twisted until it was no longer acting like a stream of ejected debris, but like a directional antenna. The event wasn't subtle. Several amateur astronomers captured it in real time using solar filters and tracking systems, and their footage confirmed what NASA had already seen. Within a span of 8 minutes, the entire dust tail of 3I Atlas coiled forward, locked in alignment with the sun, and then, just as suddenly, dispersed in a shockwave pattern. Not away from the object, but outward in concentric arcs, like the ripple of a detonation. The dispersion formed a perfect hexagonal bloom, symmetrical, stable, and shockingly fast. Atmospheric scientists were brought in to verify that this wasn't an Earth-based lensing artifact. It wasn't. What we saw was a structured shockwave, not from an explosion, but from a directional reversal. The anti-tail had turned, and with it came a wave of questions. One explanation floated in defense circles was that this might be a chemical tail reversal, a known, though extremely rare phenomenon where sublimated materials react violently to sudden solar input, causing a tail to distort temporarily. But there was no spike in outgassing activity, no increase in velocity, no chaotic motion. Instead, the reversal was smooth, even deliberate. This led to a more unnerving possibility, that what we were witnessing wasn't a chemical phenomenon, but a vector realignment, as if the object was calibrating itself in space using its own tail structure. In aerospace engineering, this would be like a drone adjusting its thruster angles to pivot mid-flight. But with a 10-kilometre-long object and no visible propulsion, this concept veered into the realm of the impossible, until one signal changed everything. Shortly after the reversal shockwave, the European Space Agency's swarm satellites detected a low-frequency pulse, a magnetospheric whisper, trailing behind the arc of the tail. The frequency wasn't random. It matched the lower harmonic of Earth's Schumann resonance, a frequency our planet produces naturally through electromagnetic interactions. And now something out there was mimicking it. This wasn't just bizarre, it was calculated. The flipped tail wasn't acting like a cloud of dust. Anymore, it was behaving like a signal array, a lens, a mechanism. And for the first time in this event sequence, scientists began to entertain the possibility. 3I Atlas wasn't just responding to Earth's energy, it was sending something back. As the tail slowly collapsed and faded into background interference, one line from a European report was leaked later that evening. The object now appears to be aligning its tail structure as a vector response mechanism, suggestive of artificial recalibration, not fragmentation, which raised a terrifying follow-up. If this was a signal, who or what was it meant for? When the tail reversal event faded from visible observation, many assumed the anomaly was over, but the reality was just beginning to unfold, not in the visible spectrum but deep in the low-frequency bands monitored by planetary magnetic observatories. Within 4 hours of the tail shockwave, a persistent rhythmic signal was detected across 5 separate ground stations. At first, the readings were subtle, a slow, pulsing electromagnetic fluctuation, not strong enough to register as noise on general arrays, but just coherent enough to form a pattern when overlaid. This wasn't just a background artifact, it was resonating with the same fundamental beat as Earth's molten core. The correlation was unsettling. Earth's core doesn't produce sound, but it does create a low-frequency electromagnetic hum. It's the result of convective movements in the liquid outer core, wrapped in our magnetic field, modulated through the crust. This natural pulse forms part of the geomagnetic resonance that surrounds every living being, and now 3I Atlas was pulsing in sync with it. The signal wasn't strong. In fact, its subtlety made it more disturbing, because it implied control. Unlike a flare or random discharge, this pattern was shaped, almost refined, like a metronome slowly aligning with a planetary beat. Scientists from the Finnish Institute of Geophysics cross-referenced the frequency spectrum and concluded that the pattern from 3I Atlas matched the second overtone of Earth's core harmonic. That shouldn't be possible. Nothing drifting between Earth and the Moon should be able to replicate a deep Earth electromagnetic profile, unless it was intentionally scanning and recalibrating to that specific frequency. The question emerged again, but sharper. What kind of object can not only detect our planet's deepest signature, but respond to it? Attempts were made to jam the signal from Earth-based transmitters, but nothing disrupted the pattern. It wasn't being broadcast in a traditional radio band. It was embedded in magnetic modulation, the kind that doesn't need a transmitter, only a moving charged field. That realization led to one of the most chilling reports from the European Geospace Consortium. The signal is being produced through ambient field resonance, not through directed emission. This suggests the object is using Earth's own magnetic structure as an amplifier. In simpler terms, 3I Atlas was using our planet as a speaker. The tail, previously dismissed as a dust feature, was reclassified as a magnetic vector funnel. Its reversal had positioned it perfectly between the Earth's magnetic poles, and now it was aligned like a transceiver, absorbing, modulating, and releasing pulses back down the same channel it listened to. To the human eye, the comet remained still, but in the deep band, the one our bones don't hear, but our atmosphere does, it was singing. For decades, we've understood comet tails as two primary structures, one made of dust, the other of ionized gas. They form as solar radiation, and the solar wind interact with the comet's nucleus, pushing material outward. These tails are passive, reactive, beautiful but dumb. They respond to energy, they don't create it. At least that was the model until 3I Atlas defied every assumption. On December 19th, after the tail flipped, researchers using the magnetospheric imaging array in Arizona noticed something troubling. The tail wasn't just redirecting, it was channeling. When visual data from L1 satellites was cross-mapped with charged particle flows, it revealed a structured pattern. Not radial, not chaotic, but spiral. The particles weren't dispersing from a source like they would from a normal tail. Instead, they moved in a coordinated wave, almost like a rail. This changed the entire framework of what the tail might be. Think of it this way: a garden hose on Earth sprays outward. That's how a standard comet behaves. But this was different. It resembled a siphon, a directed tube pulling and pushing plasma with purpose. This had design language, and worse, it had timing. Several bursts from the tail coincided with microfluctuations in Earth's ionosphere, not seconds apart, not even milliseconds. The changes were simultaneous, implying faster-than-light reaction, or more realistically, preemptive calculation. It knew when the Earth's fields would flex and responded in advance. That's when astrophysicists at the Trivector Lab proposed a bold theory. The tail is not a debris structure. It is a sensing and signalling organ. A sensing organ. The word wasn't used lightly. The structure displayed feedback loops, harmonic resonance, and what appeared to be redundancy layers, meaning if one part failed, another took over. The comet didn't behave like a rock being eroded by heat. It behaved like an apparatus with function and contingency. It's not yet known what material the tail is composed of, but spectroscopy ruled out normal dust. Silicon, carbon, and iron weren't present in the proportions expected. Instead, strange ratios of monatomic elements like gold and palladium were detected, elements known for their reflective and conductive properties, often used in spacecraft technology. Why would a natural object carry those? Why would they be aligned along its tail and not within its nucleus? And why would those metals activate only after the tail's reversal? Because the tail, many now believe, may not be part of the comet at all. It may be the primary mechanism, and the body we thought was the core, merely its vessel. By the time the tail's unusual structure had been identified, attention shifted to another anomaly, the region closest to the Sun. Normally, comets exposed to extreme solar radiation disintegrate, but 3I Atlas had not only survived its perihelion, it had seemingly used it. Infrared readings from the solar orbiter revealed a burst of heat not coming from the Sun itself, but from within the core of 3I Atlas. At the moment it curved past the solar horizon, a heat spike was registered, symmetrical, narrow-band and centered at the nucleus. Solar physicist Dr. Naoko Iseri described it best. It wasn't solar output bouncing off the comet, it was the comet responding with output of its own. The data pointed toward a sudden release of energy that matched the signature of a low-thrust ion acceleration, something we associate with spacecraft propulsion. But this wasn't a satellite, this was a comet. Or was it? The mechanics were chilling. The comet had passed through the Sun's lower coronal stream, dipped toward perihelion, then flared, not in disintegration, but in symmetry. The heat didn't explode outward. It focused down the tail axis as if something inside had been ignited. That's when Dr. Patel from the Indian Institute of Solar Engineering dropped a bombshell theory. What if this was not a comet at all, but a solar engine designed to harvest energy from perihelion and convert it into controlled trajectory? Imagine a machine that only activates when close enough to a star. One that uses the intense plasma winds to generate internal power, align sensors, and trigger a phase change. That would explain why the tail reversed after the Sun pass, why the heat originated from within the object, why the motion changed from drifting to calculated deceleration, and it would explain why Space Force had no choice but to deploy a sensor swarm, because they weren't tracking a rock, they were tracking a mechanism that had just turned on. At 3:43 a.m. UTC, radio stations near American Samoa and Easter Island reported a simultaneous short-duration spike in low-band radar distortion. It wasn't a local event. It wasn't geomagnetic interference. It came from above. A coordinated sweep by the US Pacific Monitoring Array revealed a vertical funnel of electromagnetic scatter, about 50 kilometers wide, descending from the upper ionosphere directly down to a point roughly 400 kilometers east of Pitcairn Island. No satellites were overhead, no aircraft were logged, but something was speaking through the atmosphere. And then it got worse. Hydrophones placed along the Pacific seismic cable picked up a harmonic tone, not from geological shifts, but from sound pressure in the ocean column. It was faint, low, and precisely modulated at intervals of 28 seconds. The tone pulsed for exactly 4 minutes, then stopped. But while it played, sensors around the Pacific Rim picked up minute variations in both ionospheric density and Schumann resonance. To put that in perspective, it was touching both sky and sea in perfect synchronization. Multiple agencies, from NASA to the Australian Space Authority, attempted to triangulate the source. They narrowed it to a region of open ocean with no known seamounts or volcanic activity, and then they overlaid the timing and discovered it aligned perfectly with the moment 3I Atlas entered a phase of optical dimming near Earth orbit. The tail was no longer visible in full spectrum. The nucleus reduced brightness, but down here, in our ocean and sky, the signal remained. Experts proposed 2 theories. One, that the comet was reflecting ambient Earth signals, focusing them into a beam. 2, that it was receiving, relaying, and then responding, not to the Earth, but to something beneath it. And here's what chilled the oceanographers most. The signal came from above, passed through Earth's magnetic layer, and exited in a spiral pattern, traced along undersea ridges that form part of Earth's oldest tectonic plate. It wasn't noise, it was a scan, and the ocean had just answered. As analysts continued deciphering the Earth-side effects of 3I Atlas, meteorologists from the European Centre for Medium-Range Weather Forecasts spotted something odd, not in space, but in the atmosphere. Over the Pacific and Indian Oceans, clouds had begun organising into spiral patterns, not hurricanes, not cyclones, but vast, slow-forming spirals that didn't match any weather model. The shapes were subtle, barely perceptible on standard satellite imagery, but infrared enhancement revealed symmetrical whirls that didn't rotate around pressure centres. They didn't spin like storms. Instead, they pulsed. Every spiral was forming in sync with a magnetic fluctuation logged from the orbiting path of 3I Atlas. Every 3 hours a new ring would appear and then disappear. At first it looked coincidental. Cloud movement is chaotic, but atmospheric physicists ran time-frequency analyses. The conclusion: these spiral formations were following a standing wave pattern, not unlike the nodal points previously discovered in the reverse tail of 3I Atlas. Except this time, the wave wasn't in space, it was in our sky. Each spiral stretched hundreds of kilometers across. At their centers, sensors recorded microvariations in temperature, not hot enough to register as heat bursts, but consistent enough to form a thermal signature. These weren't random patches of weather, they were spatial imprints, atmospheric echoes of something larger and more deliberate. Then came the real shock. The frequency of the spirals, their interval timing. Match the pulses emanating from 3I Atlas's tail, precisely, down to the millisecond. That made it impossible to ignore. This wasn't just an interaction with Earth's magnetosphere anymore. It was an interaction with our atmosphere. Something from 3I Atlas was creating wave interference patterns that were now manifesting visibly in the clouds over the southern hemisphere. Think about that. A comet-like object, tens of millions of kilometers away, sending a signal strong enough, or tuned precisely enough, to cause synchronized behavior in our planet's weather systems. This wasn't heat. It wasn't radiation. It was harmonic modulation, the use of waveform geometry to induce subtle shifts in energy densities. Exactly the kind of behavior one would expect from a craft or structure built to interface with planetary fields. And that's why scientists are now calling this skywriting, because it's the first time a deep space object has visibly patterned our atmosphere in a non-random, repeatable, time-linked fashion. This isn't just about detection anymore, this is about communication. For weeks, 3i Atlas has been the singular focus of every telescope, satellite and deep space observatory on Earth. But that focus may have blinded us, because on the evening of December 18th, something else appeared. At first, it looked like an imaging glitch, a faint secondary blur moving just behind 3i Atlas's trajectory. But frame-by-frame analysis from the Space Telescope Array in Chile confirmed it. A new object had emerged directly from the path of the reversed tail. Unlike 3i Atlas, this second object had no visible tail, no glow, no thermal signature. It was cold, dark, and incredibly dense, a void-like silhouette against the faint backdrop of stars. The only reason we detected it at all was because it eclipsed light. Not by radiating anything, but by blocking something. And when its trajectory was mapped, it became even stranger. This new object wasn't drifting behind 3i Atlas randomly. It was following, exactly, every curve, every shift, every vector change. It mimicked the motion of 3i Atlas like a shadow bound by gravitational tether, but there was no tether, no visible connection, and the mass-to-motion ratio didn't make sense. Its trajectory suggested a gravitational mass 5 times that of 3i Atlas, yet it moved like a feather in lockstep. Some called it a drone, others a seed pod. But the leading theory now, it's a sentinel, a tailing observer, deployed at a key moment in the tail's reversal event, possibly sent to monitor, record, or even interact with Earth separately. NASA classified the object within hours as Raven 1, a code name pulled from an older protocol for unregistered orbital entries. Infrared mapping failed to penetrate its hull, and LIDAR pulses sent from satellites returned scrambled noise. That's when analysts realized something deeper. This object didn't just appear invisible to instruments, it reflected chaos. Any attempt to scan it caused localized errors in the instruments. It jammed spectral harmonics. One observatory even reported false star positions, as if the space around it warped observation itself. The implications? Terrifying. This isn't a rock. This is a dark technology, and it's now headed toward Earth, riding in the shadow of a comet that should have broken apart months ago. For the past month, Earth's magnetic field has shown signs of increased turbulence, minor pole flickers, unexpected compass deviations, and regional auroral surges far from the poles. But starting the evening of December 18th, just after Raven 1 was detected, something unprecedented occurred. Earth's magnetosphere warped, and not just at the edges. The entire polar field buckled inward by nearly 3%, a collapse never recorded in modern times. NOAA satellites documented a shift in the northern magnetic cusp, narrowing the protective funnel through which solar radiation is funneled. At the same time, the South Atlantic anomaly, already Earth's weakest magnetic zone, expanded by 11%. That expansion isn't just theoretical. It changes where space radiation can reach our surface. It alters satellite drag, GPS accuracy, and worst of all, atmospheric shielding. And it happened after 3i Atlas pulsed a symmetrical burst toward the Sun, after Raven 1 emerged, after the reversed tail locked magnetically with Earth's poles. To say this is coincidence would be irresponsible. The field collapse was captured in real time. The geomagnetic shockwave reached Earth's surface sensors in under 13 minutes. For 14 minutes after that, the Schumann resonance, Earth's global electromagnetic background frequency, spiked to levels never seen outside nuclear testing. And then, just as suddenly it stopped. The magnetosphere didn't repair itself. It stabilized in its new warped state. Why does this matter? Because every life form on Earth, including the human brain, depends on magnetic stability for circadian rhythm, neurological balance, and atmospheric shielding. And we've just lost part of that shield. The timing is too exact to ignore. 3i Atlas did something to the field. Raven 1 is now within its boundaries, and Earth's protection has thinned, just 2 days before the object's final approach. In the hours following the sensor swarm's activation, something strange began to manifest in Earth's upper atmosphere. High-altitude balloons launched over the equatorial Pacific recorded a steady rise in stratospheric ionization. But this wasn't solar-driven. There were no sunspots, no coronal mass ejections, no expected auroral activity. And yet, the instruments ticked upward, slowly, steadily, with purpose. The increase started subtly, microvolt changes in balloon-suspended sensors that would normally be dismissed as noise. But as ground teams stacked multiple data, sets across regions, the picture changed. This was a coherent waveform, not a random spike. It was travelling laterally, not descending from above, and it had a pulse, matching the same frequency that had been detected from 3I Atlas's tail hours earlier. At first, scientists at NOAA thought this was some sort of reflected anomaly, but what changed everything was the detection of trace isotopic variants in the atmospheric particles, specifically ionized helium-3. Helium-3 is rare on Earth, but it's more common in solar winds and lunar regolith. Its sudden appearance in stratospheric samples suggested that something not native to our atmosphere, had seeded the sky. But how? The object hadn't physically intersected with Earth. It hadn't entered the atmosphere. The answer may lie in a form of high-frequency resonance transfer, something akin to wireless energy transmission but on a planetary scale. The reverse tail of 3I Atlas, now seen as a vector emitter, could have directed a magnetic field wave strong enough to energize particles in our upper atmosphere from orbit. Essentially, Earth was being played like an instrument, its ionosphere vibrating under precise and foreign influence. Stratospheric wind patterns began to shift. These aren't winds we can feel. They live in the boundary between space and sky. But they dictate how radiation flows, how satellites behave, and how communications respond. And now, they were bending subtly toward the location of 3I Atlas's magnetic field emissions. One jet stream, dubbed the Southern Whisper by atmospheric physicists, showed an unexpected lateral bulge. No storm had caused it. No heat anomaly explained it. It appeared to be drawn magnetically, and its curve aligned directly with the anti-tail's position in the sky. Atmospheric physicist Dr. Kaede Nishimura offered this unsettling metaphor. It's as if a finger dragged across the glass surface of our upper atmosphere, leaving an invisible groove behind, and the air followed it. None of this proved anything, but it strongly suggested one thing: 3I Atlas was affecting Earth's atmosphere, without ever touching it. And whatever had been seeded into the stratosphere was not random. It was patterned, measured, and pulsing. The moment that set the global observatories into coordinated alert wasn't when the signal returned. It was when the repetition changed. Roughly 7 hours after the initial waveform was captured, that strange low-frequency emission from the reverse tail of 3I Atlas, the signal came back. But this time, it wasn't identical. Not in frequency, not in amplitude, not even in duration. And that's exactly what made it impossible to ignore. At first, analysts assumed it was a simple re-emission, like a rotating beam sweeping past Earth again, a natural pulse. But when layered over the first signal, the return pattern looked more like a response. It carried the same signature, modulation, but the shape was inverted in several places, and the harmonic overtones had shifted. Think of it like hearing a familiar phrase, but this time whispered, slowed, and with a question mark at the end. Radio telescopes across Chile, South Africa, and Hawaii recorded it almost simultaneously, but with just enough delay to triangulate its origin. Not from deep space, not even from the solar direction, but again, unmistakably, from the tail-facing hemisphere of 3I Atlas. The reverse tail. This tail was never supposed to behave like that. In comets, tails are typically passive. They follow the solar wind, streaming behind the nucleus. But in the case of 3I Atlas, the tail defied orientation logic. It pointed not away from the sun but toward Earth. And now it was pulsing again. Only this time, the pulse was aware. A team at the Naval Research Laboratory took the audio frequency data and did something few others thought to do. They sonified it. When played back through a low-range speaker, the result wasn't noise, it was rhythm. A cyclical low hum, followed by a rising sweep, then an abrupt cut-off, like a mechanical inhale held indefinitely. And then, a shift. It didn't match any natural magnetohydrodynamic waveforms in current space plasma databases. It didn't correspond to Jovian bursts, solar flare harmonics, or cosmic microwave background interference. In fact, its most uncanny feature was not what it sounded like, but what it didn't. There were frequency gaps, almost engineered silences, like someone carving holes into sound itself. Engineers and data analysts referred to it as a scar signal, not because of its damage, but because of its spacing. The data looked as if something had been intentionally removed, not just missing due to interference. These scars made the message, if that's what it was, feel precise, not organic, not wild, structured. Theoretical astrophysicist Dr. Emil Hartmann made a quiet comment during a live-streamed roundtable that silenced the room. If the first signal was a broadcast, the second feels like a reply. That suggestion, that something might be engaging in a two-part transmission cycle, couldn't be ignored. Even if no one was ready to call it communication, the behavior suggested memory, iteration, learning. Other nations joined the listening grid within hours. Japan redirected 2 of its radio observatories. Germany activated a deep-frequency translator, typically reserved for moonbounce experiments. Even private space firms began offering antenna time, pushing back other missions. Everyone wanted to hear what would come next, or if anything would. But the third signal never arrived, at least not yet. Instead, the second waveform persisted for just over 38 minutes. Then it faded, not abruptly, but gradually, almost like a fade-out engineered into a track. The silence that followed was heavier than the sound. What remained was data, and in that data, a pattern, different, not random, and unmistakably from 3i Atlas's reversed tail. Now the question was no longer, did it speak? It was, why did it change what it said? By the time the second signal faded into silence, the skies above Earth were no longer just passive watchers. The full deployment of the Space Force's sensor swarm had completed its first orbital pass. A lattice of fast-response satellites, equipped with multi-spectrum optics, hypersensitive magnetometers, and near-infrared interferometers, had surrounded the predicted trajectory of 3i Atlas. It was a global net, a digital shell, stretched out in the void, waiting. And for a brief moment, it seemed like that would be enough. The swarm, designed for real-time triangulation and rapid anomaly detection, began streaming back high-frequency data. Each node communicated with the next, feeding into a live composite map. The idea was simple in theory. If 3i Atlas did anything strange, emitted heat, twisted its trajectory, released particles, flared light, anything, the network would catch it. Not minutes later, but in seconds. But it didn't play out like that. At first, the data came in clean, too clean. No new outbursts, no deviation from orbital modelling, no unexpected spikes. The comet, if it was even behaving like a comet anymore, was gliding smoothly, silently, predictably, and that's exactly what disturbed the analysts, because according to the swarm's telemetry, 3i Atlas was no longer slowing down. That detail sent a quiet wave through the mission control teams monitoring the swarm. The deceleration previously observed as it passed Jupiter, a subtle drag likely from interaction with magnetic fields or interstellar dust, had stabilized. But now the object's velocity had not just plateaued, it was slightly increasing. Not much, not enough to call it acceleration, but enough to remove doubt. Something had changed, and it wasn't due to gravity. The swarm's lateral images, tuned to detect micro-movements and light curve anomalies, captured flickers at the nucleus, moments of shimmer, like heat mirages, but without thermal signatures. It was as if the object was refracting space itself, not emitting energy, but bending the medium through which light passed. Several satellites tried to sync the flickers across frames, but none could track them consistently. The patterns wouldn't hold. It wasn't a failure of the swarm. The systems were working, the data was coming in, but what they were tracking was no longer something behaving according to conventional physics. And now the very question of what to look for was collapsing. Speed, brightness, tail movement. None of these told the full story anymore. And then came the telemetry loss. 3 satellites, perfectly healthy seconds prior, reported intermittent blackouts. Not from system failure, but from signal distortion. A kind of artificial eclipse, as if something had passed between them and 3i Atlas. But when recalculated, the trajectories showed no obstruction. Nothing was there, no dust, no flares, just missing time. For 34 seconds, one of the swarm's core relays sent back corrupted data. Not empty, not glitched, just unreadable. The digital equivalent of static printed in a font no one had seen before. And just like that, mission confidence slipped. The Space Force didn't stand down, but they stopped speaking publicly. No more updates were pushed, no more press briefings. The telemetry feeds, once publicly shared with research universities, were rerouted. Encryption keys were changed. Analysts were pulled off site. The network remained operational, but now entirely silent. The swarm had locked on. But whatever 3i Atlas had become, whatever it was doing now, it was no longer trackable in human terms. This wasn't about detection anymore. This was about understanding. And suddenly Earth didn't have enough tools left. On the morning of December 19th, when the sensor swarm locked its gaze on 3i Atlas, humanity thought it was one step ahead. We had launched our best eyes into orbit, surrounded the anomaly with precision instruments, and built a digital perimeter meant to understand everything. But what came back wasn't clarity. It was silence, gaps in logic, missing time, flickers of something just outside the range of explanation. And that changes everything. Because this was never just a comet. It never behaved like one. From its reversed tail and misaligned spin to its non-thermal jets and trajectory shifts, each new observation contradicted the last. And now, as we approach its closest moment to Earth, the very tools we built to see it are failing to understand it. Whatever 3i Atlas is, it's not hiding anymore, but it's not revealing itself either. It moves just enough to provoke, not enough to confirm. It exists in that narrow zone between evidence and mystery, where science begins to reach its edge and silence becomes its own kind of message. This isn't a countdown anymore, it's a reckoning. So wherever you're listening from, whether it's under clear skies or from the glow of a screen, keep your eyes on the sky. Because the moment that changes everything may not arrive with noise. It may not show up on radar or on headlines. It might be happening already, just beyond the last signal we can understand.